Okay, one more logarithmic scale, and this one is the pH scale, which is used in chemistry to measure how acidic or how basic, or the other way to say it is how acidic or how alkaline something is. If something is an acid, it means it has a lot of free-floating hydrogen in it, and so this pH, which Germans came up with, is short for proportion of hydrogen in something. And there are formulae for this one. They're a little bit weirder than we had for the Richter scale or the decibel scale, but they work in generally the same way. The first one is that the acid or alkaline difference is 10 to the power of the pH difference. Or, working back the other way, the pH difference is log base 10 of the acid or alkaline difference. So this should look pretty similar to the other ones that you've seen. You've got something that you're measuring. It used to be earthquake amplitude or sound loudness. Now it's acidity or alkalinity. And it's 10 to the power of how different two things are on the scale. Now, there's one more thing that you need to know to work with the pH scale, and that is that you can use it in two different directions. If something is more acid, if it contains more acid or if it contains more hydrogen, then the pH will be lower, which is a little weird. We're usually measuring acidity, and you'd think more acid would mean the numbers go up, but actually lower pHs mean more acid. And if something is more alkaline or more basic, this workbook uses alkaline, so I'll stick with that. More alkaline means the pH goes up. So on this table, battery acid is very strongly acid. Not as acid, not as much, not as much. 7 is neutral. Something with a pH of 7 is considered to not be acid or base. Acid or alkaline. And then we get alkaline, more alkaline, quite alkaline, very alkaline indeed. Okay, so in addition to working out a number in questions like this, you're going to have to pay attention to, did they say more alkaline or more acidic? And then make sure that you shift in the proper direction with your pH difference. So let's try some. Tomato juice compared to pure water. Pure water is a 7. Tomato juice is a 4, so our pH difference is 3. Our acid-alkaline difference is going to be 10 to the 3, which is 1,000. Okay, so it's a difference of 1,000, and now looking on the scale, we can say, you could either say that vinegar is 1,000 times more acid, or you could go the other way and say pure water is 1,000 times more alkaline. Oops, sorry, I was pointing at vinegar. My bad. These two. You could either say that tomato juice is 1,000 times more acid than water, or you could go back the other way and say water is 1,000 times more alkaline than tomato juice. So I'll just put that in one more time to remind you. This is the acid end of the scale, and down here is the alkaline end of the scale. Okay, eggs versus water. Eggs are an 8. Water is a 7, so our pH difference is 1. 10 to the 1 means 10. So eggs are 10 times more alkaline than water, or water is 10 times more acid than eggs are. Okay, here they're asking the same thing. If we're doing eggs, eggs are actually less acidic than pure water by a factor of 10. So if they're phrasing it that way, and this is kind of a weird way to say it, we'd say eggs are 1/10 as acidic as water is. Right? Water is more acid, so here we're going less acid, less acid, less acid all the way down. So a difference of 1 here means eggs are only 1/10 as acid, or 10 times as alkaline as water is. Milk of magnesia, down here. is 1,000 times as what? As blood. They're comparing milk of magnesia and blood. Here they are. Magnesia has a higher pH, which means it's more alkaline. It's a milk of magnesia is 1,000 times as alkaline as blood. If we flip that around, we could say blood is 1,000 times more acidic than milk of magnesia. Something is 100 times as acidic as normal rain. Normal rain is 5. We want something more acidic than that, so we're going to be going in the acid direction. But how far? This is one where we actually need our pH difference. Down here it says pH difference is the logarithm of your acid or alkaline difference. So if they're saying 100 times as acidic, and you want to know what that means as a pH, the pH will be log base 10 of your 100, which comes out to 2. So normal rain is a 5. We're saying this is 2 steps more acidic, meaning our pH must be 2 lower than normal rain. That means our pH is 3. They must be talking about vinegar. All right. More acidic means lower pH, and then this formula tells us how much lower? 2 steps lower. And now the same thing going the other way. If eggs are 1/10,000th as alkaline, what difference is that? Log base 10 of 1/10,000th is minus 4. Pause and check it on your calculator if you don't believe me. So eggs are 1/10,000th as alkaline as what? What has a pH 4 steps higher than eggs? I say higher because we're going in the more alkaline direction. Starting from 8, we go up 4, we end up at a pH of 12. They must be talking about washing soda. Eggs are a little bit alkaline. Washing soda is extremely alkaline. All right. Pretty weird, huh?